Hey guys, today we're going to upgrade the Cats API we made last episode by adding authorization. It's usually not a good idea to make your own login, since you'll be on the hook for keeping people's passwords secure. So we'll instead use federated identity, where the user logs in with an external identity provider, which then tells your app who the user is. You'll often see this in action with social login, where you log into an app using Google or Facebook. There are even services like Auth0 that make it easy for an app to support multiple identity providers at once. What many login providers have in common is that they send your app the user's identity as a JWT or a JSON web token. This token can be easily decoded to get details about the user, but it can also be cryptographically verified. This will tell you whether you can actually trust the contents of a token. Otherwise, a malicious user could forge one, claiming to be someone else. What makes it possible for you to verify the token is a technology called asymmetric encryption, most commonly implemented by the RSA algorithm, which we'll be using today. To issue a JWT, the identity provider prepares some data about the user and cryptographically signs it with a private key. This private key is kept secret, but is paired with a public key, which is freely available to anyone. This public key can then be used to verify tokens, but not sign them. So anyone can verify a JWT can be trusted, but no one else can generate them. Okay, so we have our API over here, and we're first going to need to decide how we're going to secure it. So I was thinking that listing and getting the cats will remain unsecured, and so granting public access. But to create a cat, you'll need to be logged in. And to delete a cat, the cat can only be deleted by the user that created it. How are we going to get the user ID into these operations over here? Well, what we can use is a request key, which is actually just a type of lens, and it's going to be required. Now the type here for our user ID will be a string, and we just have to give it a name. And so we can then get our user ID lens, user ID lens, and start to use it. So I was thinking, so that we know whether we can delete the cat, we're going to need to actually add the user ID to the cats, which is going to require some changes over here. So to cats repo, we're going to need it inside of our database table. So let's go to the SQL script over here. If this were in production, we'd have to do a migration, but since we are nowhere near that, we can just delete our old database and recreate the table with this new spec. And so user ID will be a varchar 128, I guess. And we're also going to need to add it when we're creating the cat. Now over here, we can get the user ID from the user ID column and create it using the one from the cats. That's fine. And in cat service, we'll have to inject it in. Now, I don't typically put principal information in the data object. That's just preference. Usually I put it alongside. And we put that there. Okay, so let's go back over here where now we can pass in the user ID. And in here, we can start to determine whether we're allowed to actually delete this cat. So I think the first thing we need to do is to get the cats. And if it doesn't exist, we're going to need to do an early return. So if we give this function a name, we can then do an early return with a not found if the cat wasn't found. Now, if our user ID is not equal to the cat's user ID, then we can do another early return with a forbidden. Okay, so that is good. Does this all compile? No, it does not, because in our tests, we need to actually inject a user ID. Doesn't matter what it is, but let's just say it's going to be user1 over here. Okay, is this compiling? Yes. Is this going to pass? No, it won't. Over here, we have a user ID lens, but we never actually added anything to put it into the request key. So that is what we are going to use a filter for. So inside server filters, there's bearer auth, and we can inject the user ID lens, but then we also need a lookup over here, which is going to take the token and return the user ID. And we don't have that yet. So since we are working with the cat service here, I was thinking we would go and add a verify method over here, which takes the token and returns the user ID if it's valid. How are we going to do that? Well, we are going to use a JWT library from Auth0. And we can go and get it into our app by pasting this into our build Gradle and converting it to Kotlin. And let's look at the docs over here. So creating a JWT, we don't need to do that yet. We do need to verify it though. So let's copy this stuff for now and go back to our cat service where we're just going to paste that there. So we need an algorithm, but most importantly, we need a JWT verifier. So let's go and require that to be injected in. And then we can, JWT verifier, verify the token and then return the subject. So the subject is basically the user ID. Now, we also need to catch this verification exception, and this will be thrown if the JWT can't be verified. So let's do that. We're going to wrap all this in a try, then catch the JWT verification exception, and then we're going to return null if it's thrown. Okay. So we are going to need to inject this into our cat service. So let's go to main, where we need a JWT verifier. And this is actually going to take a couple steps. So if we go back over here, the JWT verifier is created from this. And if we go and fix all this, we're going to need an algorithm. So what we could do is we can inject the public key into the environment. So the public key is usually tossed around as binary. So we'll say that it's a base 64 and it's required. In order to get our public key, we need a key factory. So we get an RSA key factory, and we're going to generate a public key from a key spec, which we need first. So the key spec, now these public keys are often thrown around in an X509 encoded key spec, which we create from the byte array. So from our environments, we get the public key, and then we decode the base 64. So into our key factory, we can toss the key spec, and we should have our public key. And now we can create an algorithm for RSA 256, and we can pass in the public key and the private key. Now this public key is actually needing to be casted to an RSA version, but we don't need the private key at all, so it can just be null. So we've got the algorithm, and we're going to want to verify the issuer, whether it actually came from the identity provider that we want it to. We also want to verify the audience, which is ensuring that the JWT is actually for us. So we need to inject those into our environments. So the issuer is a string, which is required. The audience is another string, which is also required. Okay, let's get those in. Okay, now we can pass that in. Cool. We can run our test and, oh yes, I've completely forgotten that we need to actually inject how we're going to verify the JWTs coming in. So from here, we can just take the verify function and now that works. But then we actually need to continue processing our request. So we wrap it in another routes block over here and move this over. So for just these methods over here, we're going to apply our bearer authorization filter and then process these routes. So this should compile, yes. Our cats test will fail because we need the public key. So let's get that in. Over here, we can create a key pair using a key pair generator. So we get an instance for RSA, and we're going to initialize it with the key size. 2048 is a pretty good one. We generate our key pair. Now we need to get our public key in X509 encoded base 64. How the heck are we going to do that? From our key pair, we can get the public key, and we can get the encoded, which we can base 64 encode. Okay. Let's see if that works. Issuer is required. Okay. Issuer of CATS Identity Provider. Audience of CATS app. Okay, let's run that. Okay, all right. So all of our unauthenticated operations have succeeded. It's just the authenticated ones. So over here, we expected a not found, but we got unauthorized. And that's because we never passed a token into this operation. But that is actually a good thing to test. So let's test for unauthorized, and it should be unauthorized. However, here, we are expecting this to be not found. So we're going to pass in a bearer auth token, but we actually need to create one. So let's go over here, and we're going to create a function to create a token using the user ID that we pass in. So if we go back to our auth0 docs over here, this is what we need to actually generate the token. And where you can ignore this exception here because we're not going to do anything stupid in our tests, hopefully. So we have a key pair, but we need an algorithm. We don't need the public key, but we do need the private key, which needs to be casted to the RSA private key. And then we can return this token. We want to set the issuer, we want to set the audience, and we also want to set the subject. So in JWT speak, the subject is the user ID, essentially. But we're going to need to get these, which right now are just hard-coded. So let's go and make them into constants. So the issuer is equal to CATS Identity Provider, and the audience is equal to CATS app. Let's go and replace these. Whoops. And then replace these. Okay, we can create a token. So we can go over here to delete cat not found. We can create the token with user of user1. However, there are also some other cases that we want here. We also want the case where we are forbidden from deleting the cat because we aren't the user that created it. So let's go and create a cat and say that it was made by user 2 and update the ID over here to actually belong to a cat. That should be forbidden. So the difference between forbidden over here and unauthorized is that unauthorized means that the app doesn't know who you are. Whereas forbidden means the app knows who you are, but says you're not allowed to do this anyway. However, I just had an idea. Over here, we're testing the unauthorized case where we don't put a token in at all. But let's test the case where it's unauthorized due to bad token, whereas this is for due to no token. So let's just pass in foo over here, and that should still return unauthorized. So let's run this test, and delete cat still failed because I forgot to pass in the token. So it needs to be user 1. And that still fails because our approval test has changed. When we added the user ID to the cats, it now has to be approved in the outputs. Now, if we didn't actually want the user ID going in this JSON, we would create a DTO, a data transfer object, so that we can have a difference between what we're working with internally and what we're working with in JSON. But we don't care about that so much right now. I think it's fine to have the user ID in the JSON, so we will just approve it and continue. Okay, so now it is create cat that is failing. So all that we need to do is just set a token for any user, and that should pass. But what I'd also like to do is try creating a cat and testing the unauthorized case. So we just want to check if it has a status of unauthorized, and there is going to be no forbidden case for create. So let's test that, and it still fails. Unauthorized, we got okay. Oh, yes, because I was authorizing the request. Okay, now this fails because the approval test needs to be updated, which we can do right now. Okay, and that is all good. So we just tested with our own key pair that we generated here. But this isn't going to be useful for actually running the app. You're typically going to have a identity provider or a social login provider or something like that. It's almost always going to be distinct from your API unless you're doing some OAuth flows. But we can do something simple. Let's create a web app over here, and this is going to return a set of routes. For the route path, we are going to make a get, which is going to return a response with HTML. So we are actually going to need the HTML here. Now, where do we get this from? Well, if we choose our identity provider, which in this case I'm going to use Google Sign-in for web, they are actually going to give us the HTML that we can use. So I'm just going to go and copy that and paste it in. However, it is requiring a Google Client ID and a redirect URI. And all that stuff we don't have quite yet. So let's go over to setup here. And it says the first thing you need to do is go to the Google Cloud Console and create a project. So let's do that. Let's create a new project, and we're going to call it cats. Then switch to it. And we need to configure our app for Google Auth first. So we're going to call this the Cats app User support email is going to be that, I guess. The audience will be external. I can't create internal because I'm not a Google Workspace user right now. Contact information will be support@catsapp.test, I guess. No one's ever actually going to be using that. And I definitely agree to the terms of service that I have not and probably will not ever read. So now we can go and create a client. And this is going to be a web application. We'll call this Cats Web Dev, I suppose. And we need the authorized origin, which is the URL where we're going to be trying to log in from. So right now, that's just localhost. And we need to redirect the user to a page with the token that Google's going to give us. So we can think ahead and say that we're going to send them to a redirect route, like this one. Okay, so we have our Google Client ID. Normally, you would not be sharing your client secret to randos on the internet, but I'm going to delete this as soon as this is recorded, so don't even bother. Okay, so we have this client ID and secrets, and we can start getting this prepared. So the client ID is going to be a string. The redirect URI is going to be URI. And let's replace these in. And let's add it to our main function here. It's not actually going to be needed for test at all, so we can create it right here. So the client ID we need to get from our environment. So we're going to need the client ID, which in Google's case is actually just the audience. So we can go and do that. We're going to need the redirect URI, which we will need to create a parameter for. So it is a URI and it is required. Okay. Now we can add this to our API by making a new routes function over here where we pass in the API and our web app. Except this doesn't compile because it's expecting a vararg of routing HTTP handler. And this is one, but this is not. However, behind the scenes it is, I just wasn't declaring it as such. So now that compiles. Does everything compile? Yes. Can we run it? No, because my database is not running. So let's get that going. Okay, and we just need to give it a moment before we run. Give it another moment. All right, so we need the public key. So, where do we get that from? If we go to Advanced Topics, verify the Google ID token, the public key is available in JWK or PEM format. So let's get this, except this key here is going to expire. We can't just copy paste this and put it into our environment. We're going to need to load this page and parse the keys. Now this is in the JWKS format, and we are actually going to need a plugin to Auth0 to do that. So if we go to examples, using a key provider, we can get this JWKS library, which we can put into our build Gradle. That, and we can go over to the example, and we are going to need all of this to get our algorithm. A bit more complicated. So let's go to main. Let's put this down here for now. Now ideally our test app would be able to replicate a JWK server, but I don't actually know how to turn a X509 encoded key spec into a JWK. So what we can instead do is make this public key optional and then add a fallback for the JWKS URI. Okay, so the first thing we need is our provider. However, let's take a step back and say if the public key exists, then we are going to do all of this. Let's just give this a name and use it there. And this is conflicting. The name shadowed. Okay, let's call this Java public key, I guess. Alright, now our fallback over here, we are going to create this provider and convert this to Kotlin. And so over here, they are just giving the domain as a string, and behind the scenes it's going to go to a path that it thinks that the search will be at. But in this case, Google is different. So we actually need to pass in an entire URL. So to create one, URI.create, that's the Java URI, where we can get our HTTP4k URI, which we then need to convert to a string. And then we can turn our Java URI into a URL. Lots of work just to get that, but that's how it is. So it's definitely good practice to cache, because otherwise it will be getting the JWKS every single time we verify, which is overkill. These aren't going to be changing very often. In fact, it looks like this caches for 24 hours. The next thing is we need an RSA key provider. So instead of copying that, let's make our own. And this will need a couple different methods implemented, but thankfully we don't need the private key to verify, so we can just set those to null. And over here, we can get from the provider, we get the key by the ID, access the public key, but then we need to upcast it to a RSA public key. Okay, now our algorithm, RSA256, can take the RSA key provider, and we have our algorithm. Let's get rid of this. All right. So let's try to run, which will fail because we need the redirect URI. Redirect URI, which in this case is localhost 8000 redirect. Did I spell that right? Almost. We're also going to need the issuer, which is, let's find out what that is. So the issuer is google.com, okay. And then the audience is the client ID, which we can copy from here. Is that everything? Yes. However, one thing I've forgotten is that I actually need to set up the redirect in our web app over here. So for redirect, we bind to a post, and we will get a request which has a URL encoded form body with our token. So from that, we can get the form parameter called credential, singular. And normally you would have some rich web application which will take this credential and do stuff for you. But since this is just a tiny little proof of concept to get us going for our API, we are going to return a response that just has the token as a string. Now, it actually found an optional string because there's no guarantee that this request has that form parameter. So let's just fall back to error, I suppose. Okay, so let's rerun. Let's go to our app. And we have the sign in with Google button, which we can then sign in as me and give Cats app permission to see a couple things about my profile. And there is the token. Since we don't have a rich web app over here, what we can do is use curl to test this. So let's just do a sanity test. Let's just start by getting the cats, which is empty. Let's then perform a post to create a cats. So the name is going to be Athena, who's actually right beside me right now. Oh, she's asleep. She's so cute. And she was born on 2022, September 4th. And her breed is American Shorthair. And her color is brown tabby. And that will fail because we are unauthorized. We never put in the token. So we can do that with an authorization header. So authorization bearer, where we paste this very long JWT. Oops. Oh, singular. Oh, I hate navigating. Singular. There we go. Nope. 500. Cannot obtain JWKS from localhost 8000 redirect. Yes, of course. Why are we using that? So for a we're supposed to use the JWKS URI. Okay, let's try that again. Oh, what's wrong here? JWKS URI is required. Oh, I never set that. Okay, so where do we get that from? Back on the Google Docs, we can get the public key in JWK format, which is right here. Let's copy that. And retry once again. There we go, that succeeded. And we can do one final check over here. And even though we're unauthorized, we can still get the cats. So that's it. That's testing with our own JWT key pair, and then that's actually integrating with a social login provider, like Google in this case. And that's pretty much it. We're done. So that was how to secure your API with JWT. Today we used Google Sign-In, but the beauty of JWT is that it can be easily reconfigured to work with any other identity provider. Let me know in the comments below what you'd like to see next. Otherwise, the next topic will be how to integrate OpenAPI into our server, which makes it easy to generate interactive docs automatically. And that's it. See you later.